Today we're going to look at applying the sine and cosine law for obtuse triangles. Our goals then would be to simply apply the sine and cosine laws as we learned with acute triangles, but today we also want to understand what the negative 2ab cos c part of the cosine law does. So let's start out with the sine law, and we'll do two examples. As we discussed in the last unit, it is always a good idea to make a little sketch. And when I make my little sketches, I always look for that biggest angle, and that helps me draw the picture. So in this one right here, I'm just going to draw two sides, and I'm going to try to draw 105, and it doesn't have to be perfect, but there's where I'm going to put C, and then that would be 105, and if big C is over there, little c is going to be over there. And now you can put the other angles wherever you want. So I'm going to put angle B down here, really doesn't matter. I'm going to put angle A up there, and then I'm going to label what I know. All those things we talked about in the last unit. And what we really want to then figure out is little a and little c. So the cosine law is written right there, so all I'm going to do is I'm going to plug the numbers in where they go, and then we're going to go ahead and solve the two problems. It's a over sine of a. Now we don't know angle A, but we do know that all the interior angles of a triangle add up to 180 degrees. So when we do that quick calculation, A turns out to be 46 degrees. Little b is 30 over the sine of 29, and little c we don't know, but it's over the sine of 105. So right now, remember when we talked about triangles, sides, bigger sides are opposite bigger angles, and little sides opposite little angles. What we should know from this is angle B, 29 degrees, is the smallest angle. Therefore, little a and little c should be bigger than 30, and little c should be the biggest angle because angle C is the biggest, or angle little c should be the biggest side because big C is the biggest angle. So I'm going to do this really quickly. I'm just going to imagine the C stuff wasn't there, and I'm going to isolate A. I'm going to multiply both sides by sine of 46. So I'm going to do this really quickly because you just finished the unit before, and this is what we did. So I'm just going to isolate that, do my algebra really quickly, and when I punch that all into my calculator, I get 44.5 units, whatever my number is. When I do the little c calculation, similarly, I'm going to isolate c. I'm going to multiply both sides by the sine of 105 degrees, and when I do that algebraically, I get this. And again, when we punch this into our calculator, what we end up with is 59.8. And those numbers make sense to me because they're bigger than 30, and as we just talked about, I figure I'm right. Okay, let's do one more. Again, always start off with your triangle and put the biggest angle on the side. So in this one here, angle A is going to be 140 degrees, and little a is 20 over there, and C, I'm just going to plonk it down there, and B is up there. So little c is equal to 25. Similarly, where angle C is 25, angle B is going to be 15 degrees. 140 plus 25 is 165. 165 plus 15 is 180. So I'm going to set up my equation. And when I set it up like this, I always put my known combo in the middle. So there's my little a over the sine of big A. It really doesn't matter, but it's just going to make things simpler to solve. And what we end up with again is just going ahead and doing our algebra. If we're going to isolate B, we have to multiply the sine 15 over. So we end up with 20 sine 15 divided by sine of 140. And And when you punch that in your calculator, you get 8.1. And similarly with C, we're going to multiply both sides by sine 25. And we're going to get little c is equal to 20 sine 25 over sine 140. Punched in our calculator, 13.1. And again, those numbers should make sense. So then the question is, well, we're looking at different triangles. This unit, we're looking at obtuse triangles. How is using the sine law in the examples above different than using sine laws for acute triangles? And what you should notice is there is no difference. It's exactly the same procedure, no problems at all. So that's really nice. Okay, then the cosine law. Well, the cosine law is a little bit different. So let's start off the cosine law and look at a 90-degree triangle. So here's our C, A, and B, and I'm going to give us a specific example, 3 and 4. And if we're going to go ahead and figure out little c here, well, little c is going to be 5. So let me write that in because it's an easy one to do. 3 squared plus 4 squared, 9 plus 16 is 25, and the square root of 25 is equal to 5. So this is a nice example, and what I want you to recognize and we've talked about this last unit, what I want you to recognize is this is the Pythagorean part. Pythagoras is in the cosine law. If we plugged in the numbers here, here's what we would get. 3 squared plus 4 squared minus 2 times 3 times 4, the cosine of 90 degrees. And if we then went ahead and found all the numbers, I'll just do this extra little step, then what I hope you would recognize is that this thing right here has to equal 0. The only way this equation can be true is if it equals 0. So we've never talked about the cosine law with respect to Pythagorean theorem because that last little part of Pythagorean, or that last little part of the cosine law goes away. So in a right triangle, negative 2ab cos c has to equal 0. It has to. Because Pythagorean theorem works by itself. We don't need that extra stuff. And negative 2ab cos c does equal 0 because the cosine of 90 degrees equals 0. And that's what you learned last day when I had you push all those buttons on your triangle. So let's look at the cosine law of an acute triangle, what we did last unit. And we're going to make this picture kind of the same. We're going to use the same numbers, sides of 3 and 4, but in this case, what can we say about little c? Well, little c has to get smaller. So if you imagine bending those two legs on that triangle, what would happen is the side opposite angle C has to get smaller. And again, because 70 degrees is smaller than 90 degrees. So algebraically, negative 2ab cos c has to be negative. And this can only be true if cosine is positive, which it is. Because negative 2ab cos c, remember we want it to be negative. Well, the first symbol is negative, a 2 is a positive, the a is a positive, the b is a positive, and the only way for this whole thing to be negative is if this last sign is positive. So a negative times 4 positives is a negative. And if we go back and look at plugging in numbers, like we're going to use the formula, here's what we'd end up with. 3 squared plus 4 squared minus 2 times 3 times 4 cos of 70 degrees. And we've done that calculation before, so we're not going to do it again. So finally, what has to happen when C is obtuse, greater than 90 degrees. So again, I hope you would look at this quick little picture and understand that the side opposite angle C has to be bigger than 5 because we're stretching it out. We're going from 90 to 110. I mentioned earlier about an elastic band. That elastic band is stretching. So little c has to get bigger than 5. Remember, our right triangle number has to get bigger than 5 because 110 degrees is bigger than 90 degrees than our right triangle. Then algebraically, this side will get bigger if negative 2ab cos big C has to be positive. So if negative 2ab cos C is positive, then we're adding on to the basic Pythagorean theorem. And this can only be true if cos C is negative, which it is. Because negative 2ab cos C would be, well, there's my minus, which is negative, then that's a positive, that's a positive, that's a positive. And the only way this whole nasty mess can be positive is if cos C is negative. And in that picture right there, when you multiply all those signs together, you end up with a positive. And again, if we were going to use the cosine law, we would just plug everything in and use our calculator. Cosine of 110. So let's do a quick couple of calculations. I'm going to actually do number 4 first. And again, always get in the habit of drawing yourself a triangle. So here is angle C. Makes drawing the triangle easier. And I'll put A right there, 6, and little B right there. So big A, big B, and what we want to know is we want to find little c. So I'm going to write down the cosine law. It's always a good habit to get into. And then I'm just going to plug everything in. So we have 6 squared plus 4 squared minus 2 times 6 times 4 times the cosine of 120. And at this point right now, you could plug everything into your calculator just as it's written and hit enter. But I'm going to do a couple of things first to highlight something important for the next one. So I'm just going to go ahead and do this because I want to highlight that these two things right here are like terms, and this thing right over here is not a like term. So when we do this on our calculator, the calculator knows that and keeps that on track, but I wanted to highlight that. So when you actually punch 36, when you actually punch in 36 and 16 and subtract 48 cos 120, the answer is going to be that. But remember, that's c squared, so c is equal to the square root of that, which is this is 76, 8.7. So again, we're just plugging in, doing like we did before, and using our calculator as before. So in our last one, the only other question you could be asked about triangles is filling in the side information. So I'm going to draw my triangle like that. I'm going to label my sides, and the question is asking, find angle C at the top. So we're going to go ahead and use the correct formula, which is the c squared version. And we're going to plug everything in where it goes. And when we do that, we get 30 squared is equal to 7 squared plus 24 squared minus 2 times 7 times 24 times the cosine of c, which we don't know. And as we did last unit, I suggested multiplying everything out. Don't try to do too many steps all in one go. And just as we talked about last unit, and just as we talked about the last question, this is what we have to be careful about. That is 336 times the cosine of c. It's not just the number 36. So what we want to do is we want to move these numbers over first. We want to add the opposite, and when we go ahead and do that, we get 275 is equal to negative 336 cosine of c. And now what we're going to do is we're going to get rid of the negative 336 by doing a multiplication with a division. And we're going to get cosine of c is equal to whatever that equals. So I'm going to say negative 275 over 336. And now we're going to find the angle, which is, press the second cosine. So second cosine of 275 divided by 336. And our calculator gives us 145 degrees. So there's a couple of examples of the cosine, but with a focus on as well, what does that negative 2ab cos c do as part of the formula? In the right triangle, it does nothing. In an acute, it takes away. And in an obtuse, it adds. So how is using cosine law in the examples above different than using a cosine law for acute triangles? Again, just with the sine law, there is no difference at all. Your calculator does all the work. Your calculator knows that a cosine between 90 and 180 is negative,